let's go to our formula. There are certain things it would be nice if you actually went ahead and calculated. First, I need to calculate how much time there is left in units of years until expiration. I'm going to add the local variables later, or declarations later. So let's call this I time equals I date minus date. If you remember, date is today's date. If you want to, you can always kind of check these things. Sub tata message box date. If you hit F5, it executes that specific sub. Sub is piece of code that performs a task. It doesn't necessarily return anything. So I know that date function gives me today's date. And since a date is number of days that have passed, the difference between them is how many days I have left until maturity, right? Or expiration divided by 65, just to make sure. And if you want to comment, or you could actually put the comment here. Calculate how many years to expiration. Once Excel VBA sees that single quote, the rest of the line doesn't matter for execution purposes. It's just a comment. Okay, you got that. That's our T minus T. And it would be nice to have this sigma times square root of T in there as well. Let's call it S root, which is my I sigma times SQR I time. It's one of the things Microsoft always pisses me off. In worksheets, if you want to refer to square root function, you use SQRT. In VBA, SQRT is meaningless because there is no such function. If you want to do square root in VBA, you use SQR. Go figure. Same thing with logs. In VBA, log means natural logarithm. If you want to do natural logarithm in Excel sheet, you have to do ln. There's a function named log, but it has two arguments, the value and the logarithm base. Okay, you got that too. What else? Let's calculate our D1, okay? You can think of this part as R times I time 1/2 square root of I'll go ahead and do it. Let's call it my D1 log strike over spot over strike. So I spot over I strike plus I rate times 0.5 times I sigma times I sigma. I only calculated the square bracket at this point. In fact, I need to multiply that with I time. So we've done only the square bracket. which means I'm gonna divide this by sigma times square root of I time, which I have already calculated as S root. So this is sigma times square root since I haven't declared them, it reverts to the last version I do. So I have my D1, let's go D2. My D2 is my D1 minus S root right here. I'm gonna need e to the power that thing times strike, which is basically present value of strike. So let's call that P strike or PV strike. I strike times X negative I rate times I time. You're probably thinking this is a weird way of calculating present value, but Black-Scholes assume that there is continuous compounding. I'll show you how to convert a regular function, regular interest rate into continuously compounded rate. And let's calculate. Okay. No D1 application dot worksheet function, because there is no built-in VBA function to calculate the probability under the left tail of a normal distribution. We refer to the worksheet function this way: application dot worksheet function dot name of the function norm s dist. That's for standard normal distribution. My D1, and I'm gonna be very lazy and copy and paste that. So this is N of D1 times strike, N of D2 times present value of a spot, N of D2 times present value of strike. So let's do this. If not I put, then remember I put is an indicator. If it is true, I'm handling a put option. If it's not true, I'm handling a call option. So not something means I'm doing call. Black-Scholes euro equals I spot times no D1 minus PV strike times no D2. And this is a good time for me to do my declarations. I know you can write it in one line, but I like doing it in separate lines. I think that's about it. I also like kind of separating stuff. And here's what we're gonna do. Else, we're dealing with a put option. The only difference is I now need n of minus d2 and n of minus d1. Thankfully, normal distribution is symmetrical. I don't have to calculate them separately. So here's what I'm gonna do. No d1 equals 1 minus no d1. Where? Oh, thank you. Yeah, that would have created an issue for me. Remember the cardinal rule in computer, don't compute anything twice unless you have. Normal distribution is symmetrical, so n of 1 is equal to 1 minus n of minus 1, or n of minus 1 is 1 minus n of 1. Since I already have the other tail, all I have to do is calculate it. This calculation of this computation is a lot more expensive. I mean, not too much, but probably 10 times as much.